Welcome all. This is Suresh, lecturer on ECE from Government Polytechnic Bellanpalli. Today I am going to teach the electronic device and circuits subject. The subject code is 18EA 303C, which is a common subject for ECE and instrumentation students. Today's topic is Today's first topic is draw the basic block diagram of a feedback amplifier and explain. First, see the basic block diagram of a feedback amplifier. If you observe in the block diagram, from the left side we have the signal source, which is connected to the comparator or mixer network. Mixer network mixes two or more signals, so we have one signal as source signal and another signal is coming from the feedback network, and the output of this comparator or mixer network is given to the basic amplifier, and the amplifier's output is provided across the load resistor RL, that is the V output. But there is another block that is called the sampling network. This network is a circuit which will take the sample out of the output of basic amplifier, only some proportion, and given it to the input of feedback network, and the feedback network's output is given to the mixer network, is connected to the mixer network. And the current direction, if you see, I in into the basic amplifier and IO is equal to I load, I output is equal to I load current, and the A and beta are the respective gains of the basic amplifier and feedback network. IF is the feedback current. So this is the basic block diagram of a feedback circuit. Any feedback circuit will have these blocks. Now see, the block diagram of a feedback amplifier is shown in the figure. It consists of a basic amplifier with gain A, a feedback network, a sampling network, and a mixer network. Now we have to see the working, that is the explanation of the working of feedback amplifier. First, what do you mean by basic amplifier block? What does it have? What it will do? The function of this stage is to amplify the signal that present at its input, not the source. In the block we have the signal source, but for the basic amplifier that may not be the input. The input is from the output of mixer network. So the basic amplifier will amplify the output of the mixer network. The voltage gain of the basic amplifier without feedback is A. So we have seen here A is the gain of basic amplifier, that is also called the feedback of the circuit, the gain of the circuit without the feedback network. Next is sampling network. It is used to sample the output, that is either voltage or current. The sample signal is fed to the feedback network as shown in the figure. As already we have discussed it, the sampling network samples either voltage or current and will give it to the and feed it to the feedback network, right? Now the feedback network, what does it consist of? Feedback network, it is a passive two-port network. Passive means it has only the passive components, no active components. Means the signal whichever is provided to its input is not altered, I mean it's not distorted. The original shape is preserved. It may consist of resistors, capacitors, and inductors. Most often it is simply a resistive configuration, that is a purely resistive network. It provides reduced portion of the output as feedback signal to the input mixer. Reduced portion of output means we are taking only the sample of the output, not the complete output. Remember, it is called a sampling network. It will take only proportion, that means at least 10% of the, or 1 to 10% of the output, and given it to the feedback network. It has a feedback network has a gain of beta, so it will be a little bit amplified version of the sampling portion, sample portion. So it provides the reduced portion of the output as feedback signal to the input mixer network. Why it is called input mixer network? But means the feedback output is connected to the mixer network. So mixer means here it will mix at least two signals. So one signal is from the source and another signal is from the output of feedback network. So the feedback voltage Vf is given as beta into V output. Here Vf, we can say feedback network output Vf is equal to beta times of the V output, not the complete V naught, it is a small portion of V naught, where Vf is the feedback signal, beta is the feedback factor or feedback ratio. The value of beta lies in between 0 and 1. So that is the important point here. The resistive network does not actually amplify the input signal. It will just convert the little portion into required portion of the mixed network. So value of beta is always lies in between 0 and 1. It is totally different from the beta symbol used to represent current gain in common emitter amplifier, which is greater than 1. So we have seen beta in which mode? Common base mode. In the common base mode we have seen the beta which is actually greater than 1, which is typically value from 50 to 200, but it is not that beta we used here, remember it. Next, mixer network. Using mixer network, the feedback signal is combined with the signal from the source and the result is fed into the amplifier properly. Using mixer network, feedback signal is combined with the signal from the source and the result is fed into the amplifier properly. The mixer signal mixes the two signals, obviously. Next, the sampling and mixer networks. Sampling network. There are two ways to sample the output according to the sampling parameters, that is either voltage or current. First is the voltage sampling. The output voltage is sampled by connecting the feedback network in shunt. Underline that word. The output voltage is sampled by connecting the feedback network in shunt across the output, as shown in figure A. Voltage sampler. If you see this, the upper figure, in which that is a voltage sampler, that means the feedback network is connected in shunt, that is in parallel to the output. This type of connection is referred as the voltage or node sampling. Voltage sampling decreases the input impedance of the amplifier, right? Voltage sampling decreases the input impedance of the amplifier. Is it the input impedance? It is the output impedance actually. Voltage sampling decreases the, correct here, voltage sampling decreases the output impedance of the amplifier because the sampling is connected across the output, right? In shunt, in parallel. In parallel, if we connect two resistors, the resultant resistance will be the lesser. So the output resistance will decrease. Now see the current sampling. The output current is sampled by connecting the feedback network in series with the output as shown in figure. If you want the current sampling, that should be connected in series with the output. This type of connection is referred as current or loop sampling. Current or loop sampling. The current sampling increases the input impedance of the amplifier. Actually, it is the output impedance, not the input impedance. Current sampling increases because in series, if we connect two resistors, the resultant resistance will be higher compared to the both the resistors. Now the mixer network. The feedback signal may be mixed with the input signal in two ways, two basic ways, that is shunt mixing. Figure C. It's in the figure C. If you see in the shunt mixing network, we can connect the feedback network's output as either in shunt or in series. First see the shunt mixing. Shunt mixing, figure C, the feedback signal is connected in shunt with the input signal and is called the shunt mixing. Shunt mixing decreases the input impedance of the amplifier, because in this case input impedance is correct because the shunting connects the input, connects at the input of the amplifier. So let us assume the input impedance of this amplifier as Z and the feedback network is connected in shunt. The resultant input impedance of the amplifier will be less than the Z. Next is the series mixing. In the figure, the feedback signal is connected in series with the input signal and is called the series mixing, right? In this case, series mixing increases the input resistance of the amplifier, obviously, because the series mixer in that feedback network is connected in series with the input impedance of the amplifier. In resultant, the resistance will increase. Now we have to derive the expression for gain in a feedback amplifier, because we know the gain of a amplifier without feedback is A, and the basic block diagram we have seen, we have the signal source, mixing network, followed by basic amplifier, followed by sampling network output, and the sampling network output is connected to the feedback, which is connected to the mixer network. With this setup, the voltage gain, the gain of the amplifier will be affected. So now we have to see the expression for gain in feedback amplifier, and first consider the negative feedback amplifier shown in the figure. The signal which is to be amplified is Vs, source signal. The gain of the amplifier without feedback is A. Negative feedback is applied by feeding a fraction of the output of voltage V0 back to the amplifier input. See the figure. This Vs is the source signal, amplifier, basic amplifier with gain A without feedback, and the output is V0. And by doing a sample, by collecting a sample of the output, we have given it to the feedback network with a feedback ratio as beta, and that output of feedback, that is Vf is equal to beta V0, is applied to the mixer network. Observe the output of mixer network, that is Vin is equal to Vs minus Vf here, minus Vf. Vs is the actual signal source and Vin is the input voltage, input signal we apply to the amplifier. So the input of the amplifier will be Vin, not the Vs. And output of mixer network Vs minus Vf, because we are applying it as a negative feedback. We are subtracting the Vs and Vf. The feedback factor of the feedback network is given as beta is equal to, obviously we know, Vf by V0, where Vf is the feedback signal and V output is the output signal. Therefore, the actual input to the amplifier is the signal voltage Vs minus feedback voltage Vf, actual input. So the actual input Vn is equal to Vs minus Vf, which is equal to Vs minus, see, from Vf we have beta V0, and output voltage V output is equal to output voltage. What is the output voltage? Gain A into Vin, not the Vs, right? So Vn, A into Vn, A into Vs minus beta V0. So V output we have so by some mathematical equations, see V output, take the common V output, 1 plus A beta is equal to A Vs. V output by Vs is equal to A by 1 plus A beta. So we got V output by Vs. See, Vs is the signal source to the whole network, that is with the feedback network. Vs is the input to the total network. Vn is the input to the only amplifier. So overall output by overall input, we got the overall gain of the network or circuit, which is a feedback, negative feedback amplifier. So but V output by Vs is the voltage gain of the amplifier with feedback, is denoted by AF. Remember, AF is the feedback gain, voltage gain with the negative feedback. AF is equal to A by 1 plus A beta. Remember this is a very important formula. The negative feedback thus decreases the gain of the amplifier. See, A by, we have 1 plus A beta. 1 plus A beta factor, it decreases the overall voltage gain A by this factor. So with the negative feedback, we have the overall voltage gain AF is equal to A by 1 plus A beta. And gain of amplifier with positive feedback, we have seen the gain of amplifier with negative feedback. Now we have to see with the positive feedback. In the case of positive feedback, the voltage feedback Vf is in phase with the applied voltage V0, in phase. See, in the negative feedback, output of mixer network is Vs minus Vf, that is out of phase, right? But in the positive feedback, output of mixer network will be V input is equal to Vs plus Vf, that is in phase with the source signal. So after all doing those equations again and mathematical derivations, we get AF is equal to A by 1 minus A beta. 1 minus something, it is less than 1. So obviously A by less than 1, which will get more than A. The application of positive feedback therefore increases the gain of amplifier. Remember, the application of positive feedback increases the gain of amplifier. Application of negative feedback decreases the gain of amplifier. The amplifier gain with feedback is called closed loop gain. This is very important term. So AF is also called closed loop gain, because the loop, you can see, it forms a loop, closed loop gain, because it is the gain on closing the feedback loop. Next is the comparison of negative and positive feedback. What are the advantage and disadvantage, where we use, this comparison of negative and positive feedback. First, the process by which a fraction of output energy of some device is feedback to its input is known as feedback. The process by which a fraction of output energy of some device is feedback to its input is known as feedback. This is the definition of a feedback. Depending on whether the feedback signal is in phase or out of phase with the input signal, there are two types of feedback. Sorry with this little corrections in the PPTs, some problem with the software. So two types of feedback are possible. They are positive feedback and negative feedback. Observe the diagrams. Figure 2.22a. First, V input is applied to the amplifier, that is introduces 180 degrees phase shift, and which is fed back to the network, introduces again 180 degrees phase shift. So Vf is in phase with the Vin, because in the closed loop we have 180 plus 180, totally 360 degrees or 0 degrees. So that will be is in phase with the V input. Now figure 2.22b, same circuit but with the phase shift of 0. Feedback network introduces 0 degrees phase shift. In that case, Vf is in 180 degrees out of phase with the Vin. So first diagram is in phase and second diagram is in out of phase because of the feedback network phase shift. In the upper diagram we have 180 degrees phase shift introduced by feedback network. In the lower diagram we have feedback network introduces 0 degrees phase shift. So positive feedback, when the feedback signal voltage or current is in phase with the input signal, it is called positive feedback. The positive feedback is also called direct or regenerative feedback. These are the another names for those positive feedback. They are also called direct or regenerative feedback because it will regenerate addition. Positive feedback, it will generate the signals. It increases the gain of the amplifier. Obviously we have seen the derivation also. AF is equal to A by 1 minus A beta for positive. It will be a little bit confusing. The positive feedback, we apply the signal in plus, but in the derivation we get the final output AF is equal to A by 1 minus A beta. However, it has the disadvantage of increased distortion and instability. This is important. These are the disadvantages of increased distortion and instability. That means continuous increasing of gain leads to the instability. Therefore, positive feedback is seldom used in the amplifier. Seldom means very rarely. Okay, na? So one important use of positive feedback is in oscillators. This is the very good application of positive feedback. In the oscillator circuits, in order to generate the waveforms continuously from a small portion of input signal, that is from the DC sources, we get a continuous AC. In that case we need positive feedback. So the concept of positive feedback is illustrated in figure 2.22a. Already we have seen, that is both the amplifier and feedback network introduces a phase shift of 180 degrees. That is 180 degrees, not the 1800. Please correct it. Both the amplifier and feedback network introduces a phase shift of 180 degrees. Here in the first diagram, figure 2.22a, amplifier introduces 180 degrees phase shift and the feedback network also introduces 180 degrees phase shift. Overall the loop phase shift will be 180 degrees plus 180 degrees, that is 360 degrees, that is in phase. The result is a 360 degrees phase shift around the loop, causing the feedback signal EF to be in phase with the input signal. Next is the negative feedback. Hold on 1 second. Right. Negative feedback. When the feedback signal is out of phase with the input signal, it is called negative feedback. As we have already seen in the block diagrams, the mixer network, output of mixer network in case of negative feedback is V input is equal to Vs minus Vf. That minus indicates negative or out of phase. So the negative feedback is also called as inverse or degenerative feedback. Underline these words. Negative feedback is also called inverse or degenerative. It will decrease the gain, right? Because in the derivation we have seen AF is equal to A by 1 plus A beta. 1 plus A beta. So the overall gain A will be decreased by some factor of 1 plus A beta. So it decreases the gain of the amplifier, and the negative feedback is frequently used in amplifiers. So this negative feedback is frequently used in amplifiers. Of course it decreases the gain, but we still use this in amplifiers because of its stability and less distortion compared to the positive feedback. The concept of negative feedback is illustrated in figure 2.22b. Already we have seen. the 2.22b, the amplifier introduces a phase shift of 180 degrees, because in the basic common emitter amplifier the output is out of phase, that is 180 degrees out of phase with the input signal. Because it is widely used in real world applications, we consider basic amplifier as a common emitter amplifier. And if the feedback network introduces a 0 degrees phase shift, that is no phase shift, then the overall loop phase will be 180 degrees plus 0 degrees, that will be 180 degrees, that is out of phase with the input. So in the negative feedback concept, as you can see, amplifier introduces a phase shift of 180 degrees into the circuit, while the feedback network is so designated that it introduces a no phase shift, that is 0 degrees. Read it as 0 degrees, read that 1800 as 180 degrees phase shift. The result is that the feedback signal Vf is 180 degrees out of phase with the input signal. So that is the concept of positive feedback and negative feedback. Now we are moving on to comparison of negative and positive feedback. In the left side we have negative feedback, in the right side of the table we have positive feedback. It just summarizes what we have learned till now. Just look into the points once. In negative feedback, the feedback signal is 180 degrees out of phase with the input signal, obviously. And in the positive feedback, the feedback signal is in same phase with the input signal. Second point, in the negative feedback, it is also called degenerative feedback, or some other word is also there. What is that? Inverse feedback. Should remember these alternative names because they come in the competitive exams to confuse you people. They don't ask directly negative feedback. In a degenerative feedback, then you will get confusion what is degenerative and what is regenerative. So while preparing for competitive exams or interview questions, these type of concepts are important. It is also called regenerative feedback. Second point, in positive feedback side we have also called regenerative and direct feedback. The third point is it reduces the net input to the amplifier. Reduces the net input because V input is equal to Vs minus Vf. So the overall net input is less than that of Vs. So the net input will be reduces. And in case of positive feedback, it is V input is equal to Vs plus Vf. So it increases the net input to the amplifier. And the fourth point, it reduces the gain of the amplifier. From the AF formula, that is A by 1 plus A beta, we have seen it reduces the gain. And positive feedback side, it increases the gain of the amplifier because AF is equal to A by 1 minus A beta. It reduces the noise and distortion. That's why we have used mostly in the negative feedback itself in the real world applications. Reduces the noise and distortion. It increases the noise and distortion. These are the disadvantages of positive feedback. That's why we don't use most positive feedback networks. And another, the most important thing in the feedback section, it improves the stability of amplifier. This is important. Stability should be maintained. Any circuit, in any circuit, the stability has to be maintained. So in the negative feedback, if you use, it improves the stability of amplifier gain. The positive feedback, it decreases the stability of amplifier gain. This is the very disadvantage point in case of positive feedback. Frequently used in amplifiers, we know it is used in oscillator circuits. So these are the summary points of the negative and positive feedback. So overall, which one is good? Though it reduces the gain by some proportion and introduces a out of phase signal in the input, the negative feedback is the best in applications. Now moving on to a small topic, that is block diagrams of feedback amplifiers. Different types of feedback amplifiers. Though it is negative and positive feedback amplifiers we have seen, but depending on the mixing and sampling, we know a sampler can sample voltage signal or current signal, and in the case of mixing also we have, it is either series mixing or shunt mixing. Depending on these two different parameters, we have four types of feedback amplifiers. So those are voltage series, voltage shunt, current series and current shunt. The first word voltage or current depending on the sampled signal. If we sample the voltage signal, we call it as voltage series or voltage shunt. If we sample the current, it will call current series or current shunt. That second word, series or shunt, come from the mixing of the signal, either series mixing or shunt mixing. So first we have to see the voltage series feedback amplifier, which is basic, very basic type and most widely used feedback amplifiers. If you observe the diagram, that is Vs signal source, signal resistance, followed by mixer network, but it is a series mixer. See the feedback network output, which is connected to the input of amplifier with series connection, and then followed by amplifier, and again we have the sampler section. In the sampler section, that dotted lines represents the voltage sampler portion. In the sample portion we have shunt sampling. Actually it is in the shunt or in parallel, we will measure actually the voltage like that, right? Voltage measured in parallel. So the voltage is sample, output voltage is sample, which is connected to the feedback network. So this type of feedback uses voltage sampling and series mixing as shown in figure. This is also known as shunt derived series fed feedback. Okay, we can call voltage sampling as shunt sampling also, right? So the shunt words and series words, if you get confused, then we should use voltage sampling and series or shunt mixing. So with the two names, we have voltage series feedback amplifier or shunt derived series fed feedback. Next is the voltage shunt feedback amplifier. So this type of feedback uses voltage sampling and shunt mixing. See the figure. In the figure we have shunt mixing. For the shunt mixing, we have represented the input as current source. So from the theorems of network, we can get the voltage source or current source, right? We can represent them in different ways. So this type of feedback uses voltage sampling. See the sampler network, we have shunt sampling, that is voltage is sample, and the mixing type, in the mixing we have shunt mixer. This is also known as shunt derived shunt fed feedback, right? Both are shunts, both are in parallel. Shunt series, shunt derived, shunt fed feedback. Now see the next one is, draw the block diagram of current series feedback amplifier. In this type, see the block diagram, we have the source and then series mixer and current sampler. Current is sampled in series. How we will measure the current in series? So for the sample signal, we should collect the current sample here. So the current sample to collect, we have to connect the circuit in series. So current sampler, that is series connection, And again in the mixing side we have series mixture. If you take the series mixture, then it is called current series feedback amplifier or series derived series fed feedback. These words may confuse you for the first time, but if you practice 1 or 2 times the block diagrams and the names, then you will be familiar with the names, you can remember easily. Next and the last block diagram is current shunt feedback amplifier. This type of feedback uses current sampling, see the sampling network, and shunt mixing, see the mixing type as shown in figure. It is also known as series derived and shunt feedback. Series derived and shunt feedback. So with this we have covered the 4 types of feedback amplifiers depending on the sampling and mixing. That is voltage series feedback amplifier or shunt derived series fed feedback, and again voltage shunt feedback amplifier, or it is also called shunt derived shunt fed feedback. And third one is current series feedback amplifier, or it is also called series derived series fed feedback. And again last one is current shunt feedback amplifier, that is also called series derived shunt feedback. So this is today's topics. Just quickly go through the summary points of today what we have learned. Right, first one is the basic block diagram of a feedback amplifier. If you see the feedback amplifier, different blocks. Without feedback we have gain as A, and with feedback we have gain AF, and the feedback ratio is beta. Then basic amplifier, what it does, you know the basic amplifier what it will do. The sampling network collects the sample, that is voltage or current, and fed back to the feedback network. And again feedback network is a simple 2-port, and it will be with a resistive configuration simple, and reduce the portion output is given to the mixer network with Vf is equal beta V0, and beta is 0 and 1, not the beta we used to use in the amplifier. The mixer network mixes the 2 signals either in phase or out of phase and fed back the input to the amplifier. The sampling and mixer networks, if you see, sampling is voltage sampling, it is also called voltage or node sampling. The output impedance, here not the input impedance, that is the output impedance decreases. In the current sampling, current is sample, it is connected in series, and the output impedance will increase. Next is the mixing network. We have shunt mixing and series mixing. See the shunt mixing. In the shunt mixing we have what signal is mixed in shunt, and it is connected to the input side, so the shunting of the resistance, input resistance, will result in decrease of input impedance of the amplifier. And series mixes, in case of series mixing we have connected the series in series connection with the input impedance, so the overall input impedance of the amplifier circuit will increase. And expressions, simple mathematical derivation of the expression. And first we derive from the negative feedback amplifier. Derivation is for negative feedback. Observe this, Vs minus Vf, and simple equation, V input is equal to S minus Vf. From the feedback network we have beta is equal to Vf by V0, and by doing some mathematic adjustments we get the AF is equal to A by 1 plus A beta, so the overall gain will decrease for the negative feedback. And the in case of positive feedback, V is equal to V input is equal to Vs plus Vf, and we get the AF is equal to A by 1 minus A beta. So with this the gain will increase, though it is in what is called denominator 1 minus section, you know 1 minus something is less than 1, so the overall gain will be increase greater than A. So positive and negative feedback, what it does actually introduces 180 degrees phase shift. The main difference is the phase shift of the feedback. If the feedback introduces 0 degrees phase shift, it will call out of phase, that is negative feedback. If the phase shift introduces by the feedback is 0 degrees, sorry, feedback introduced first feedback network if it introduces 180 degrees phase shift, 180 plus 180 360, that is in phase, that is called positive feedback. Next, if the phase feedback introduces 0 degrees phase shift, 180 plus 0 is 180 and it is out of phase with the input, so it is called a negative feedback. So that is the theory. And again, negative and positive comparison. See, the most important thing is the noise and stability. Noise and distortion reduces in case of negative, and the stability is improved and it is good in negative feedback. In positive feedback, noise and distortion increases and stability decreases. So obviously it has lesser number of application, but it also has one application, that is oscillator. Next, the block diagrams. 4 types we have seen: voltage series, voltage shunt, current series, and current shunt. So this is today's topics. If you have any doubt, please email me at sureshakul2001@gmail.com. You will get reply, but not instantly. Okay. And for the reference of this subject, you have the textbooks, standard textbooks, electronic device and circuits by Jacob Milburn and Hawkins, some publishers, and the local author books also available for these topics. And if you want to do the experiments, virtual labs, go to the vlabs.iitkharagpur.ac.in. you can do it by yourself. And if you want to practice the questions, MCQs, interview questions, different types, you can go to the Google and search for the topics. Directly you will get the links. Okay. And if you want to further read, please go to the. Now I am going to teach you how to go to the virtual apps in my mobile. If you see, just go to the Google, type vlabs.iitkharagpur.net. if you see, right, just click on that link, you will get vlabs home page. The net is slow, so we are getting a little bit slower response from the website. The registration is for your benefit only, because if you register, your all work will be saved, and whatever you complete your experiments and the results are recorded for the benefit of the student. And these are the different branches. Go to the electronics. These are advanced labs. We need the basic electronics, right? This is the page we need. Basic electronics. See the list of experiments. First, read the introduction, what we have to do, features for students, virtual labs for students. Go to the list of experiments, right? These are some basic electronics represents. Familiarization with resistor, capacitor, inductor, Ohm's law, VI characteristics of a dioid, half wave rectification, full wave rectification, capacitive rectification, Zener diode voltage regulator, BJT, common emitter characteristics, right? This is important. Common base, studies on BJT, CE amplifier, basic CE amplifier, first lecture, and the frequency response of RC coupled amplifier, differentiator and integrator, black cell, basic properties of op-amp, inverting and different. These are different lectures. You can directly click. you will learn a lot. You can learn a lot from these things. Quiz also there, theory quiz and reference books also there. NPTEL note. This is national project and technical education learning lectures. These are all free, no need to pay anything, right? No need to click on some spam mails. Directly click, you are going to download the file, lecture 1 PDF file. All this will be available. Just download. So you can learn a lot. This is the notes, basic electronics, breadboard. See the same, you see the breadboard in your labs, practical labs, multimeters, for how to connect those things. This is a small portion you have seen. You can explore a number of things on this NPTEL website, courses. The resources every time is available, ready to in your phone or at your doorstep, but it is you, actually the students have to utilize the resources very effectively. That is your part. If you want to practice some MCQs, multiple choice questions on electronics, just directly Google them. See, digital, different websites will be there. Digitech, Nopia, electronic sports, electrical for you, San Foundry questions. You will have the answers also. You can get the answers, solved examples, answers, basic concepts. Basic semiconductor questions, diode characteristics questions. From the starting point you can learn everything. Go to some basic thing. Add blocks. Use the add blocks. See the first question, the donor ions is represented by a positive plus sign. True or false type of questions. And MCQs. P-type carriers are located in the dash. If you know, it is good. If you don't know, just see the answer. With the explanation you will have the answers. There are a number of websites, not only this. So you can practice number of questions. So we conclude with this session. So that is today's topics. Just keep on learning. Thank you one and all.